There are some special triangles that, if you know, will save you a lot of work. You will often get asked about angles like 30 degrees, 45 degrees, 60 degrees. If you learn these two triangles, you will actually find it makes your life easier. You can then get exact values using surds for sine, cos and tan. And it's one of those things you just end up learning. You just learn these numbers. So start with the 45 degrees because cos and sine are the same because the two angles here are the same. So the sine of this angle is the opposite over the hypotenuse, 1 over root 2. Sine 45 is 1 on root 2. Cos 45 actually is the same because it's the same size angle. It's the adjacent over the hypotenuse, 1 over root 2. So 1 on root 2 is cos 45 and sine 45. Now you'll see here the book actually has root 2 on 2. That's because there are some people who say you shouldn't have a ratio, a fraction, where the denominator is a surd. That's because this is not a whole number. This is not a proper number. This is what these people say. I personally don't mind, but there are people who do mind. So it's one of those, again, it's one of those things you just get in the habit of doing. You don't have to at this stage, but you probably should in your external exam at the end of year 12. But at this stage, this is a perfectly good answer. But be aware your textbook always rationalises denominators. How did they get from this to this? They multiply top and bottom by root 2 over root 2. Sorry, didn't say that right. They multiply top and bottom by root 2. So the top becomes root 2 and the bottom becomes root 2 times root 2, which is 2. So 1 on root 2 is the same as root 2 on 2. This is called rationalising the denominator, turning the surd in the denominator into a normal number, an integer. Okay, if cos 45 is 1 on root 2 and sine 45 is 1 on root 2, what's tan 45? Well, tan is opposite on adjacent, or if you're using this angle, it's opposite on adjacent, which is 1 over 1, which is 1. So tan 45 is 1. The other triangle that really is worth learning, 30 and 60 degrees. I think of it as a, sorry, I should go back a little bit. I call this a 1, 1, root 2 triangle. It's a 1, 1, root 2 triangle. This one is called a 1, 2, root 3 triangle. It's just the way I remind myself of what it is. 1, 2, root 3. Now you have to remember that 2 is the hypotenuse because 2 is actually bigger than the square root of 3. This is about 1.7. So 1, 2, root 3. And then find where the small angle is, that's 30 degrees, and the big angle is 60 degrees. Okay, so what's sine 30? Well, sine 30 is opposite on hypotenuse. It's a half. Sine 30 is a half. Cos 30 is adjacent on hypotenuse, root 3 on 2. And tan 30 is opposite on adjacent, 1 on root 3. Again, the textbook rationalises that denominator, root 3 on 3. We can do the same thing with 60 degrees. Sine 60 has to be root 3 on 2, opposite on hypotenuse. Cos 60 is adjacent on hypotenuse, 1 over 2 is a half. And tan 60 is root 3 on 1, which is just root 3. It really is worth learning these. Personally, I draw the triangles each time I need to work it out, and I can then go from the triangle. You may prefer just to learn the values out of the table. It's entirely up to you.